To understand what is well, how to apply the chain rule, we need first to understand what is a derivative. So, derivative is a function which gives the slope of a curve that is the slope of the line tangent to a function. We can find a derivative by many methods. One of them is applying the definition of a derivative, which is this formula, the one we have here, and we have another for a specific point. Another method we can use are applying the rules for differentiation. Either method will give you the correct answer, but applying the rules will make you the same answer in a faster way. Okay, now knowing what is a derivative, we're going to practice some exercises. So first of all, what we want to do, as the problem says, is to find the derivative of the function. As you may see, there's a parenthesis, so the chain rule says that we need to find the derivative from outside to inside. So basically what we do is that we take down the 2, follow the rule, parentheses, 3 x plus 1 to the first power times the derivative of what it's inside, which is 3, which leaves us an answer of 6 times 3x plus 1 parentheses. We apply distributive property. Derivative of is equal to 18x plus 6. Now this one is a little bit more complicated, but as you may know, this is the same as having derivative is equal to the same as having y equals 13 x squared minus 5x plus 8, and it's the same as this is raised to the 1/2 power. 1/2. So we follow the rule. What we do is that we take down the 1/2 times what it's in the parentheses, which is 13x squared minus 5x plus 8, close parentheses. 1/2 minus 1 is equal to -1/2, so raised to the -1/2 times what is inside the parentheses. The derivative of what is inside in the parentheses will be 26x minus 5. So next step, what we do next is that we leave the 1/2 times times 26x minus 5, and we send down the negative power divided by 13x squared x squared minus 5x plus 8 to the 1/2 or squared, as you may wish to put it. So then we apply distributive property and we end up having 13x minus 5 over 2 over 13x squared minus 5x plus 8 to the 1/2 power or squared. So basically this was an example. Now let's try another. We erase this and let's try this one. Okay, y prime is equal to, what is the we take down the 1/3. 1/3 comes down, parentheses 4x plus x to the negative 5th power, close parentheses, and this is raised now to the negative 2/3 to a negative 2/3. Now we're going to practice some more complicated examples of finding the derivative and applying the chain rule with trigonometric functions. So for example, number 1, we take down the 2 and in parentheses put cosine of x cubed, and that's for a moment. Now we again apply chain rule and we put times, another parenthesis, the negative sign of x cubed, and we again apply the chain rule and we multiply times 3x squared. We simplify and we end up having negative 6x squared times cosine x squared times sine x squared, and that's our answer. Now moving on, the next, it's also a little simple, and we say that the derivative of sine is cosine of 3x squared plus x. So as you see, we are applying the chain rule. So next we apply we find the derivative of what is inside the parentheses, and we say cosine of 3x squared plus x times 6x plus 1, and that's basically our answer. So in conclusion, the chain rule is very important, so much that some people consider that the chain rule is the most important property of calculus, because We again apply it in integrals, but not directly using the derivative. It's a similar process that we use. In order to get in a 5 in your SAT, and you need to really know a lot of stuff and dominate the chain rule, because a lot of derivatives and integrals come out. So study hard your chain rule and practice a lot. That is the only way of getting good grades. Practice.